Okay, 2.4 is on more set operations. Fun. Okay, more set operations. Okay, the difference between two sets A and B, okay, denoted A minus B is the set of all elements in A, but not in B. Okay, it's basically elements in A only. Okay, the Venn diagram looks like this. Okay, this is the universal set. We have all the elements that are in only A. So this is A minus B. Okay. The symmetric difference between two sets A and B denoted A plus circle B is A minus B combined with B minus A. Okay, union with B minus A. Okay, is, so this is the symmetric difference, is all the elements in only A or only B. Okay. So nothing shared. So we have this guy, okay? So A plus circle B is equal to A minus B together with B minus A. Okay, notice that A minus B is not the same as B minus A. Okay, B minus A gives me all of the stuff only in B. And A minus B gives me the stuff only in A. Okay, the complement of a set A denoted A bar, the bar over it, is the set of all elements not in A but in the universal set. U, we'll call that U, set U. Okay, so if we have our set U being everything. Okay, that includes everything in the rectangle. Okay, but we have set A here. Then what would not A look like? It would look like everything outside of A. Okay, and nothing inside A. So this is not A. Okay, so let's list these operations. Okay, the operation, and then the notation, and then the description. Okay, the operation is intersection. The notation is A intersect B. And this description means that X is an element of A and X is an element of B. It has to be both. The union, A union B, the description is X such that X is an element of A or X is an element of B. It could be either or. Okay, or both. Either or both. Okay, the difference, A minus B, okay, is that X is an element of A and X is not an element of B. The symmetric difference is A, okay, plus circle B is X such that X is an element of A minus B, or X is an element of B minus A. And the complement is A bar, or not A, and so X such that X is not in A. Okay, okay, let's do an example. Okay, example 1. We have a Venn diagram. Okay, this is the universal set is the box. We have A and we have B. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what is A? What is set A? Set A is 3, 4, and 5. What is set B? Set B is 5, 6, and 7. What is the universal set here? Oh, that's all the numbers 1 through 9. all the integers 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Let's see what we got here. So A, what's A union B? What's A union B? Well, that would be all of the numbers in A or in B. So that's 3, 4, 5, 6, and 7. Okay. Thank you, Anthony. Thank you, Bob. What is A intersection B? What's A intersection B? Thank you, Maverick. Yeah, just 5. Just 5. Okay. C, what's A minus B? We want all of the items in A that are only A. That's 3 and 4, right? Yep. Okay, what about D? What about B minus A? These are all the items in A or B, and ours are in B, but not in A. What's the symmetric difference here? What's A circle plus B? What's the symmetric difference? Yeah, it would be A, everything that's only A and everything that's only B. The combination of the two above. Okay, F. What is A union B minus A intersection B? Oh, okay. So we have A union B minus A intersection B. Well, A union B is 3, 4, 5, 6, 7. And then we want to subtract off the intersection of B, which is 5. We want to just knock out that 5. And so that's 3, 4, 6, and 7. Okay. Cool, cool, cool. Okay, what about not A? A complement. Not A. What's not in A? Well, 1, 2, 6, 7, 8, and 9. That's not an A. Okay. What's not B? Not B is 1, 2, 3, 4, 8, and 9. And I, what is A union B complement? What is that? That's all the stuff that is not in A or B. What is all the stuff that's not in A or B? Yep, 1, 2, 8, 9. Thank you, Jesus. Yep, good job. Okay. Let's do example 2. Okay, use a Venn diagram to express the set A circle B not intersecting with C. We want everything that's not only A or only B, and we want that to intersect with C. So let's use a Venn diagram to do this. So we need circles A, B, and C. So circle A, circle B, and circle C. Oops. I don't like circle C. Circle C is a jerk. Okay, let's make these a little bigger. That one is a little misshapen. Stop it. Okay, there we go. So circle A, circle B, and circle C. Okay, so what would be A? Let's look at the complement first. What would be only A? Only A. Okay, only A would be here, right? Only A would be here. And then only B. Oops, bring it back. Okay, only B would be here. Okay, but we want the not of that. We want the not of that, right? Okay, we want the opposite of that. Okay, so what would be the opposite of that? I'm going to put that in green. The opposite of that would be this, 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 this. Oh, no, sorry, I messed up. It's not this. It is this. Sorry. Shoot. Come on, come back. Okay, this is in B, okay. Okay, and yeah, and this is, or that's an A and this is in B. Okay, so that's that. Okay, perfect. Okay. So we've got that, right? Okay, those are red, not green. Okay, and everything else is green as well. Outside is green too. I'll just say that everything outside of this is also green. That's the complement of a not A and B. We're just dealing with not A and B first. Okay. So everything that's in green is the opposite of only A and only B. That's everything that could be shared or outside of these circles. Okay. Okay, it's just not A and B. Now we're going to add C into the mix. We're going to add C into the mix. And we're going to say, okay, it must also be in C. Okay, so let's choose a different color. Let's go black here. What are the pieces that are green but are also in C? Well, it's here and it's here. Maybe I can use a thicker pen here. Okay, there. It's all the black. Okay. That's the intersection of C along with the complement of the symmetric difference of A and B. Okay, okay, makes sense? Okay. And that is 2.4.